Hey, Pastor, why do we want to find errors in software?
No programmer can avoid errors or bugs in their software. Software errors can cost a lot of money. And the cost of software errors in the US in 2018 was about $3 trillion. So finding errors in your software might save you a little bit of money. By the way, how can we find errors in our software, Matt?
The most common approach to finding errors in software is testing. When testing software, you provide the software with an input and compare the actual output with the expected output. Should these outputs differ, then an error must have occurred and can be traced back to the source using special tools. Is testing alone sufficient to check for errors, Anto?
As the famous Dutch computer scientist Dijkstra pointed out half a century ago, testing can be used to show the presence of bugs, but never to show their absence. That's why I think testing is in particular of limited use when checking concurrent softwares for errors. Hey Parsa, why does testing not work well when looking for errors in concurrent softwares, in your opinion?
In concurrent software, several components known as threads run at the same time. These threads run mostly independently, and as a result, running concurrent software multiple times may cause operations of individual threads to be executed in different orders. Usually, there are many different orderings, and testing can only check a few of them. As a result, testing might fail to find errors in concurrent software. Therefore, other techniques, including model checking, have been developed to supplement testing.
What is the most popular tool for model checking Java code, Bruce?
Presently, the most popular tool for model checking of Java code is Java Pathfinder, also known as JPF. However, JPF does not support the checking of properties expressed in a logic. Instead, it checks for properties such as deadlocks, data races, and other concurrency-related defects.
All right, Matt, why are we interested in properties expressed in logic?
Well, logics provide a general language to express a large variety of properties. In particular, it allows us to express two kinds of properties of software, namely safety properties, which assert that the software does not do something bad, and liveliness properties, which assert that the software does something good. For example, a logic formula can be used to express the property that the balance of a bank account never becomes negative.
Bruce, just wondering, is there a solution to test concurrent software for errors?
Yes, we present JPF CTL, an extension of JPF which supports the checking of properties specified in the logic named computational tree logic, or CTL. Now we are going to present you with our demo.
Okay, so a demo is worth 1,000 words. So today we are going to demo the bank account class. And what essentially should happen is that we are going to first do consecutive deposits and then consecutive withdrawals. And we are doing the same number of deposits and withdrawals, and we're going to try and assert that a bank account should never be negative. Now, if the program behaves as expected, it will perform the deposits first and then perform the withdrawals second. Now, we have tested this 1 million times and no bug has been found. In other words, the bank account has never been negative. However, it is in fact possible for the bank account to be negative, and we will show that using JPF CTL. So what I'm going to do is I'm going to choose the class that I want to test. In this case, that is the main class of the bank account. I'm going to enter a formula in CTL. And this will be ag not example dot main dot negative. And we are going to select that the class does contain a package declaration, because in this case it does, and I will press the run button now. As you can see here in the console, output is coming out, and when it finishes we will get a pop-up. So what this says is that model checking is finished for the selected class and the written formula, and that it has been determined that the formula does not hold in the initial state and is considered invalid for this system. So a bug was found on our very first run of JPF CTL, where it took 1 million cases before and no bug was ever found. And in fact, we can follow this counter example and find the exact state in which the bank account becomes negative. In this case, it is state 5533.
First, the Java code is modeled as a state transition graph. This kind of state modeling makes it possible to represent complex system states without the need to know the exact structure ahead of time. Second, the property that we are interested in must be expressed in computational tree logic, or CTL. The algorithm is going to first check if the CTL syntax is valid. Then a custom Lexer parser will be executed to generate the corresponding parse tree for the input formula. After that, our model checking algorithm takes the CTL formula and the state transition graph as inputs, then starts the verification process. Finally, if the property is determined to be violated by our algorithm, JPF-CTL will generate a report with a counterexample, which can be later used by developers to identify the source of the error within their code.
Our CTL model checking tool, named JPF-CTL, developed by Anto, Bruce, Matt, and Parsa, will allow developers to automatically verify that their Java code satisfies properties expressed in CTL, and thus allow them to discover flaws in their code and prevent costly errors.